And here comes a bit harder part. We need to get V2 and H2. How do we get it? And how does a force plate help us in this lab? It gives us time, right? Because it's going to bounce on a force plate 2 times, so you got a time interval of the fly time, right? And we're gonna use that time to calculate V2 and H2. And as mentioned previously, those equations look so complicated. We want to simplify it by making one of the velocity 0, right? So we're going to basically make it a free-falling motion. So if Vi is 0, this equation will transform here like this, much simpler. And also if Vi is 0, that'll be this one. Much easier, right? Okay, you don't need to remember the equation right now. We'll go through it again. So this is a motion, and this graph is how you should be able to see on a force plate after you plot it out. So we're going to plot the graph together later in next video, so don't worry. So after process the force plate, you'll see the y-axis is the force, and the x-axis is a frame number. So like the ball drops, and it hits the force plate at this instant. So there's a peak on the force plate. And then this peak, the yellow peak, is here, happens here, right? And then the ball goes up. So there's nothing on the force plate. And then it hits the force plate again, here on the orange arrow, here on the orange arrow. So between two peaks, we should be able to get a time, right? That's the fly time in this motion, right? So if, for example, we found that, oh, there are 1,000 data points in between these two peaks, and we're sampling in 1,000 hertz. That means we got 1,000 data per second. So 1,000 data points here means the time is 1 second in between two peaks. So that's why the frequency is so important. You won't be able to analyze the force plate data without knowing the frequency of it. So this interval is this interval. After it hits the ground and reach the apex and get down. But we want to simplify the equation. We want to make one velocity 0, right? So we only care about the first half of the motion here in the yellow box. Because at the apex, velocity is 0, right? So during this motion, the time is half of the time you see on the force plate. So that's from this peak to the middle of two peaks. That's super important, like most people make an error here. Alright, how do we deal with that? So we see how many data points are there, you get a time, right? And then we get 1 over 2 t. That means how long does it take after bounce until reach the apex? And because velocity at the apex is 0, so analyzing this interval, we can simplify the question. How do we do it? We're going to use these two equations. V equals to gt, that's from here. V equals to Vi plus AT, but Vi is 0. A equals to g. And also, h equals to 1 over 2 gt squared. That's from this equation, but we make Vi 0. Alright, so gonna use these two equations. Remember, the t is just half of the whole time you see on the force plate, because we just care about this motion because one of the v is 0. And for example, say on the force plate you see there are 500 data points between two peaks. How much time are there in between two peaks? It's recording 1000 hertz, right? So how long does it take to generate 500 data points? 0.5 seconds, right? Use 500 divided by 1000. That's 0.5. But 0.5 is the whole flight phase. We only care about half of the flight phase. So we take 0.5 divided by 2. That's 0.25 seconds from after bounce until reach the apex. Right? And we'll put the time here, 0.5 second, into this equation. So you got 9.8 times t, 0.25. You got V2. So this V2 is a V2 you want to find. No problem. Makes sense, right? And then the same thing, we put the time here, but remember, we simplify the question, so we only care about half of the motion. So t is 0.25 squared times g times 1/2. That's the h2 the ball can reach. Alright. So think again, how do you get coefficient of restitution? You need V1 and V2, right? Or H1 and H2. V1, V2, H1, H2. How do you get those numbers? H1, you've already been given, right? 1.5 or 1, depending on the situation. V1 is related to the height, so you can put the height into an equation to generate V1. For V2 and H2, we're going to use the time recorded by the force plate, and then put it into an equation. You got V2 and H2. And the time, you need to care about the frequency on the force plate, and also we only care about half of the flight phase. Right, so here's the equation you need. You got V1 and V2, put in there, you got coefficient. You got H2, H1, take a square root, you got the equation. So that's simple.